Our next speaker is Dr. Michael VandeHaar from Michigan State University. He grew up on a dairy farm in south central Iowa, if I remember correctly, and did his bachelor's in biology at Dordt College, and then his PhD at Iowa State, and since then has been at Michigan State University. Technically, he was one of my professors. I guess I won't give the years for both our sake, but he's been working in ruminant nutrition, mammary biology development, growth health, and looking at lifetime feed efficiency. And he will be, his title of his presentation today is Nutritional Strategies to Enhance Sustainability and Efficiency of the U.S. Dairy Industry. And please welcome Dr. Michael VandeHaar.
Okay, thank you. It's a pleasure to be here today, and the year, as I understand from Casey, was something back like 2000. That's much easier for you to say than for me. But the next thing I want to tell you is that where I really started thinking about the whole issue of sustainability and efficiency was when I was in graduate school, and this man, Don Bites, was my major professor. And I won't give the year, but he got me thinking about the idea that animal products are luxury foods. And I don't know if you remember talking about this, but we had lots of great conversations. And okay, so if we don't really need them in our diets because people can live healthily and happily without them, we need to think carefully about growing them in a very efficient and sustainable manner as we can. So what I'm going to talk about today is a kind of a combination of things from ideas over the last 20 years, especially in the last 10 years. I've had the pleasure of working with geneticists to try to come up with genomic breeding values for feed efficiency in dairy cows. And that's been a lot of fun, and I think it's really important to think about how we interact with geneticists and nutritionists in the future. So I saw this, perhaps some of you are aware of this product. Perfect Day is putting out an animal-free dairy protein. They are not selling it yet, as I understand, but it's coming out. This is some information from their website. And I'd just like to point out a few things. Okay, a smaller hoof print, okay, less water consumption, less greenhouse gas emissions, etc. And they're going to produce dairy proteins by yeast cells that receive sugar and then go through fermentation and make caseins. It's a brilliant idea, and I really quite like what they're doing. I'm not particularly pleased with some of the stuff they put on their website when it comes to what they talk about in the modern dairy industry, and that is 1/4 of all greenhouse gas emissions can be traced to agriculture, with meat and dairy responsible for a whopping 60%. As much as the top oil and gas giants. And it's just interesting that these two developers are both of Indian origin. And in my view, I want to be culturally sensitive here, but India has 300 million cows and they aren't very productive. So when you look at greenhouse gas emissions per cow or per unit of milk, they're probably one of the worst. So, and now it seems to me like they're saying this is what the U.S. industry is like, and we're not. And I particularly like this statement, tastes like dairy without any of the guilt. I don't really feel guilty when I eat dairy products unless my wife catches me eating ice cream right before I go to bed. And I know I shouldn't. So what I want to talk about this morning is, and I had till what, 11:05, 11 o'clock, right? Okay, the basics of feed efficiency. How are we doing now? What can we do next? And what questions must be answered? Okay, so I just point out, and you've seen some stuff already about feed efficiency, sustainability. It's complex. And we need to think about foods that are consumable by humans, foods that are not consumable by humans, and even that is not simple because there are foods that people could eat, but they don't want to eat. So defining how to put things in these two categories isn't easy. We have a lot of other inputs that go into the industry. And then the outputs, we typically think about the the foods that we get out of the industry, but there are also other products that are produced that are not consumable by humans. And in fact, some of the waste could in fact be captured. And if we do a good job of capturing and using all the waste from cows, the environmental impact can be considerably less. But even a flow like this is not adequate because we need to consider all the other things that are ways that our industry impacts society and the environment. In particular, we've already talked about climate impact. I think a big one is ecosystem services. The whole idea that our lands have value to wild animals and native habitats. Soil erosion is a big one that we really need to think harder about how what we do today impacts soil erosion and the future possibilities for growing food. And I will skip over the rest. But the point is, one metric cannot do justice in this system. But as a nutritionist, and especially when working with geneticists, we try to simplify the system and come up with just a few traits. And the one trait I'm particularly going to talk about this morning, and I'm interested in, is gross feed efficiency. And this is the percentage of feed energy that is captured in milk and body tissues. And we could look at, I hit the wrong button there, but okay. So we have gross energy in food. Some of it's lost because it's not digested, or it's lost as methane or urine or body heat, which is directly correlated with CO2 production. And that gives us a net energy value for a food. And then some of that net energy is lost because it's needed for maintenance of the animal, and some of it's captured as milk and body tissue. And to improve gross feed efficiency, we can focus on this arrow, or we can focus on the second one, okay? And we have done some of each, okay? We can feed more digestible feeds and well-balanced diets to improve net energy from gross energy, and we can also focus on maximum production, because when we focus on increasing productivity, we dilute out maintenance, and that has had a huge impact on efficiency in the past 100 years. Okay, so if you look at milk production in the U.S. over the past 100 years, it's been on a steady incline. And in fact, the rate of increase is probably even increasing, is going to speed up instead of decrease in the next 20 years because of our current trends in genetics. And there have been a whole lot of reasons this has happened. A big one was that we started to understand quantitative animal genetics. But you could attribute this to lots of different things, but genetics has been a major player. Along the way, okay, so today, the average milk production in many states is about 12,000 liters of milk per cow per year. Certainly we have herds that are around 15,000, even some higher than that. And as we've increased our milk production, we've also increased gross feed efficiency. And as we've increased gross feed efficiency, we've also decreased the greenhouse gas emissions per liter of milk. Okay, so, and this was a study from Capper et al. It showed that we now produce only 40% as much greenhouse gas emissions per liter of milk as we did, say, 1950-ish. Now, this improvement in efficiency, and I would argue sustainability, has come along not because we were really intent on trying to do anything good for the environment, but because we were interested in getting more milk per cow, because that's how farmers make money, okay? And this was a byproduct. So let's just talk about that. And I think most people are probably aware of this, but the whole idea of the dilution of maintenance is this: that when cows eat only enough to maintain themselves, they don't gain or lose body calories, and they're not producing any milk, they're not pregnant, 100% of their food is used for maintenance. If they eat twice as much energy, now half of their food is used for maintenance, and if they eat 3 times that amount, now only 1/3 of their food is used for maintenance, and we can go on and on. So as cows eat more and produce more per day, a smaller percent of the food they eat is used for maintenance, a greater percent is converted to product. Okay, we can look at data to support this. This is based on about 5,000 cows, and you can see that the line goes up, not exactly the way the NRC would have predicted from 2001, but in a similar fashion. Okay, so not only are we more efficient when we look at gross efficiency, as we once were, but if you think about land use, and this has already been talked about, so I just point out the most efficient way to eat would be if we ate pig feed, okay? Corn and soy, or grains and lentils, whatever, rice and lentils, something like that. So I did a little analysis several years ago. Perhaps it was too simplistic, but I simply said, okay, if I put things in equivalence and try to use an acre of land, growing corn and soy, give me the same proportions of calories and protein as I would get from milk. A grazing farm, you need about twice as many acres to produce food for humans as if you put that land into production. But with a high producing, confined, modern dairy farm like we find in Michigan, with no byproduct feeds, everything grown on the land, you can get about, you only get half as much food for people from a hectare of land as if you ate corn and soy directly from that land. But if you consider that dairy products can have about 30% of their diet coming from byproduct foods like cotton seeds or soy hulls or corn gluten feed, now you can get almost as much food for humans from a hectare of land as if you had grown corn and soy. And corn and soy are the absolute most efficient way that we could eat. Our vegan diets are not that efficient. Okay, and I'm going to skip over this one. The simple point, I think you've seen things like this already. The point of this study was that some dairy in a diet, some animal products in a diet is more efficient than complete vegan when you think about land use. And just looking at greenhouse gas emissions, just a second, this was a study from 10 years ago in Scandinavia, pointing out that soy drinks are perhaps a little better when you think about greenhouse gas emissions per unit of nutrient supply for people than milk, but not that much different. And I would argue that they were using numbers for milk production from Europe, and in the US were more efficient than that. So if you looked in the US, I have not seen an LCA on this in the US. There probably is one out there. Please tell me if you've seen one. I'm going to guess the two numbers are closer together. And of course, that doesn't bother most people. We don't think about things that way because it never stops me from drinking one of my favorite foods, which is not anywhere as efficient as milk. Okay, so we don't live this way when we think about most things that we do. And it's a little troubling to me that we get so caught up about it when it's the food part of our diets instead of the other fun things that we like to do. My favorite foods are salt, caffeine, alcohol, and chocolate, and I don't even consider their environmental impacts. Okay, so we made a lot of progress in the last 9,000 years. And most of the change we've made has been through the dilution of maintenance. Okay, cows have more mammary tissue. That's the big one. We've also made progress in greenhouse gas emissions and efficiency from feeding cows more grain and from better management. But what can we do next? And I'm going to go through just a few things relatively quickly. One is genetics. We're making huge changes in genetics, and because we now have the genes of a dairy cow, well, maybe I shouldn't say genes, the genomics of a dairy cow characterized, our animal breeders are making progress faster than ever before. And through improved reproductive technologies, when I was in graduate school, a generation interval for a dairy animal was about 7 years. Now we can get down to 1 year. So we can select for greater efficiency. We have a lot of things we can select for, and we need people from other fields besides genetics to help make decisions about what we want to select for. And most geneticists that I know are perfectly happy to have other people giving them some input because it really will change the cow that we have in 20 years. One way we do this is we look at something called residual feed intake. I think I'm going to skip this, but I just want to make a point that The idea here is that cows that eat less than expected are more efficient, and our goal is to try to select for those cows. It's a heritable trait. We have genomic breeding values for it. It's being used in Europe. I anticipate it will be used in the US within the next 3 years. And it's repeatable across different types of diets, lactations, climates. And in this way, we'll be focusing not on the dilution of maintenance, but we'll be focused on, we know we can. We'll be focused on selecting animals that do a better job of converting gross energy to net energy. In the past, we focused only, really, in our breeding programs on going from animals that dilute out maintenance more because they produce more milk. Okay, we can also think about new ways to manage cows. Now, perhaps I shouldn't even call them new ways, okay? But one thing that makes it a little complicated is that if we simply focus on the amount of feed or you get per milk or gross feed efficiency, you might actually feed a diets that have more fat and less fiber. But cows are ruminants. And one of the beauty of a cow is that she can digest fiber. And sometimes expensive feeds, such as fats, may increase feed efficiency, but they're not worth the cost. So economics comes into this too. And many high fiber feeds may decrease feed efficiency. They may be worth feeding anyway. And in the big scheme of things, we should use our dairy cows as bioprocessors. So gross feed efficiency can be a little misleading. And then the other point about management, feed management, is that really what we need to focus on is not, we have too many cows that are overfed certain nutrients, in particular protein. We've made progress in managing cows by feeding total mixed rations, because when an animal gets a little bit of everything at every bite, okay, she tends to have a more constant rumen, and she tends to be more efficient and produce more milk and dilute out maintenance. However, in the process, we've also lost some of our focus on feeding individual cows. And because we no longer feed individual cows, we end up feeding a lot of cows extra protein, more protein than they need. And so we overfeed some nutrients because we simply aren't grouping cows enough. Nutritional grouping on farms is something that we really need to focus on. That isn't a research problem, or perhaps it is, because we need to think about how we can convince farmers to do it. But the other thing we really need to do more on is figuring out how to use computerized systems to try to treat animals as individuals within groups. This is just looking at the impact on efficiency for a whole farm from some different types of things that we could do. And by increasing production, we can increase efficiency of energy and protein use by doing some things with management for increasing longevity or reducing age at first calving. So reducing the amount of time animals are not being productive compared to when they're lactating. That's a way I can improve feed efficiency. And a big one for protein in particular is simply making sure that cows later in lactation are not overfed protein. A lot of farms are not doing that. And then another one is simply trying to reduce feed wastage on farms. People waste feed, cows do too. And we can do a lot better job of trying to reduce feed wastage on farms and improve feed efficiency. And this is just to point out that managing animals through lactation is one key to improving feed efficiency on farms. Animals in early lactation, middle lactation, late lactation all have different requirements and should be fed different diets. And a lot of our farms don't do that now. Okay, they feed all their animals in basically the same ration all the way through their farm. New computer models to try to help farmers understand what to do and how to manage cattle, making sure they go to the right pen and get the right diet, are one key to improve feed efficiency. And now I want to talk just a little bit about balancing diets to improve feed efficiency. So if you look at the conversion of, so I'm at the beginning part of my chart, gross energy to net gross energy to net energy. Fiber is probably the thing that is least efficient on that part because it's hard to digest. So the gross energy value of fiber is 4 kcals per gram. Cows get about 1 to 2 kcals per gram from it. People get essentially 0. Starch, 4 drops down to 2, protein 6 drops down to 2, fat 9 drops to about 5 or 6. And when we balance diets, we can think about feed efficiency and use those numbers to come up with an efficient diet. The problem is that our nutrients interact with each other. And in particular, how much starch is in a diet can alter fiber digestibility. So as a nutritionist, in the past, we've tended to think about nutrients as precursors for products. So how much lysine do you need, or how much methionine, or how much starch might you need? We just say, okay, it takes this much starch to give you this much milk. And we need to spend more time thinking about how do nutrients interact with each other, and how do they impact things like digestion and feed intake and nutrient partitioning. So just to look at that, I've got, this is a complicated slide, but I've been part of the NRC for developing new requirements for dairy cattle. And we've spent a lot of time thinking about how nutrients interact in the last 4 years. And I want to just point out this one, okay? And my goal with this slide is to show you that what really we need to spend more time thinking about is not how much starch should be in a dairy cow diet is not so dependent on how much energy it provides for milk as what does it do to intake. So if we look at the effect of increasing intake in a diet that has 26% starch, which is kind of our standard cow in the US, you increase intake and you increase the amount of milk that can be produced. If you, however, take a diet and feed different levels of starch and say they all eat the same, notice there's not really much difference in the amount of milk that will come out of this diet because starch depresses the digestibility of fiber. So I started off with a fiber digestibility of 50% if she ate 20% starch, and it dropped to 41% if she eats 34% starch. Okay, because starch depresses fiber digestibility, you don't get nearly as much milk from feeding all that starch as you might have thought, assuming that she only eats 25 kilos. And then I would also just point out that you could also feed a diet that has more digestible fiber and feed the same amount of starch as this reference cow, and that would do about the same thing as feeding more starch. The big thing that's important when we feed animals diets with more starch and less fiber is that it allows them to eat more. So if we look at how farmers typically feed cows with different levels of starch, okay, so I have my base diet, again, the same one I had up here. Now, if I assume that when cows are eating less and producing less, they're eating less starch, okay, I have a lot less energy available. When if I feed a higher starch diet and they can eat more, that really makes a big difference on milk production. And you can see the same thing, which I'll ignore here for adding together fiber and more digestible fiber and higher starch. But the point I want to draw your attention to is when you figure that, when we assume, or actually we're not assuming, we know that when you feed cows more starch, one of the things you really are doing is allowing them to eat more or enabling them to eat more. And because they can eat more and the diet is a little more nutrient dense, they produce a lot more milk. And why is that an advantage? Because then they dilute out maintenance and they're more efficient. So I want to look at some numbers then for what happens to feed efficiency. And I'm going to look at it a few different ways. And I think maybe I'm just going to go to the bottom right away and ignore the top and look at the same diets I showed you before. So we've got one cow that is either eating a low starch diet at a low intake or a high starch diet at a higher intake. And we can look at efficiency. Milk energy per unit of gross feed efficiency, per unit of feed gross energy goes up. Milk energy per unit of human edible gross energy. So I said that there are certain things in this diet, in particular the fiber, and part of the things like the gums or the, we call it residual organic matter. It's not starch, not fiber, but it's still a carbohydrate. Will probably be associated with feeds that people don't eat. Okay, so if you look at that, efficiency goes up. If you look at milk energy per unit of feed, and I said, what if people were just forced to eat cow feed? We know they can't digest all of it. So I said, what's the value in cow feed for people to eat? Don't have to think about what things people would eat. Let's just say they would eat everything that a cow gets, and they can digest what they will. Okay, feed efficiency goes up. Milk energy per unit of methane produced. Efficiency goes up. Okay, milk energy goes up per unit of methane. And milk energy per unit of heat output. Heat output would be proportional to CO2 output. As you feed cows a more energy dense diet with more corn grain, more human edible food, and they eat more and produce more, efficiency goes up. Okay, so efficiency goes up when we can get cows to eat more because they dilute out maintenance, even when they're being fed more corn grain. And surely in the future there will be more competition for corn grain from with animals and people. But efficiency goes up when we feed it, by all measures that I look at. Okay, so I'm not going to go through these slides very much. I just want to point out that the big key is what happens to intake when we feed different diets. Okay, we know that when we feed more digestible forages to some cows, high-producing cows, they're able to eat more. Lower-producing cows, we feed more digestible forages, they actually eat less. So we need to understand how intake is affected by different diets in different animals, different genotypes, different stages of lactation. That is, I think, a key for where we need to go in the future and to do a better job of understanding it. And I would also like to point out there are trade-offs whenever we think about efficiency. I showed you that most measures go up together, but there's one that is a little trickier. And that is if you try, it's almost impossible to optimize both efficiency of protein use and efficiency of energy use at the same time. This is data from my student Inhong. I forgot to put his name on this slide, but he's sitting back there, and just showed that if he fed cows, he had like 200 cows, 170 cows. If he fed them a low protein diet, they used nitrogen more efficiently, energy less efficiently. Now I'm going to skip that too. Finally, there are things we can do to crop residues to make them more digestible. This is a process called AFEX, ammonia fiber expansion. And when you can try to make that cellulosic material more digestible for cows, you can get more milk and less body weight loss compared to a really poor quality diet. This was done in India at the National Dairy Research Institute there. And our idea is that if they could use a process like this on all the cellulosic material that they have, we could substantially improve feed efficiency in countries like India or Africa. And finally, this was a study done at Kansas State, Barry Bradford's group, and he simply said, what is the value of ecological leftovers? And he made some diets that were basically just ecological leftovers, things that we really don't have much use for. Soy hulls, cotton seeds, corn gluten feed are all options in here. Hominy feed, wheat middlings. And when you do that, it all depends on what metric you use, whether or not feed efficiency goes up. What he tried to do is he said, okay, at the top, he said, here's a thrift scenario where you consider hominy and wheat midds as suitable foods for humans, okay? And in which case, then when he looked at efficiency of energy, it stayed about the same. Protein actually dropped. But when he said, you know what, those are things people aren't going to eat, even if they could, they're not going to eat them. And then efficiency went up markedly. And that's the bottom two slides. Okay, so I have a summary here, and in the interest of time, I'm just going to put this up here and all of it there and say the rumen's amazing. Cows can process things efficiently. The mammary gland is a great factory for producing product. Animal breeding is changing what cows we're feeding, and there are a number of things that we can do to try to improve productivity and efficiency and sustainability in the future. One of them that I'd just like to highlight is sensor technologies will help us monitor cows individually. And I think I covered most of the others there, and leave you with this, which is some research challenges that colleagues from NC 2040 gave me in preparation for the meeting, and the committee can have that list as they put together a report. And if there's time for a couple of quick questions, I see it's 11:02, so if you read something on there you want to ask me about, I'd be happy to talk about it.
Let's take our speaker. Any quick questions? Natalie, can you come up to the microphone and make sure you speak into it so we can have it recorded?
Mike, in the slide you presented about Enghong's work, where we're reducing the amount of protein, so you increase nitrogen efficiency. But then, did you mention that you reduce energy efficiency by doing that?
Yeah, so when you feed
can you explain why and how?
You feed a lower protein diet, the cows produce. We fed a diet that was marginally deficient in protein, because that's when you really start to increase protein efficiency.
Sure.
Okay, and when we did that, they produced less, energy efficiency went down. So yes, you could argue, well, we're going to get to right at the point where you don't lose production, but that's really hard to do on farms. We could maybe do that in a test, you know, at our university farm, where we closely monitor everything and have really close tabs on our diets, and we feed cows as individuals. But when you feed them in groups, you can't do that, because you have cows with various levels of production. They each actually have their own individual requirements of protein relative to energy, and you will almost always lose milk in the process of trying to maximize protein efficiency. So it's really hard to ever maximize both of those at the same time. In the future, maybe feeding, you know, all the perfect amino acid blend will help in a rumen protected form. But I can tell you that from our NRC committee, we just don't feel like we're close to that yet.
So maybe when you move into individual feeding computerized system.
Perhaps.
Okay.
I'm a little skeptical that we'll get there anytime soon.
Can we get the next question at the microphone real quick?
You mentioned about the role of genetics in you know, having this variability in the. So can you tell me about like what you're doing, or how can you incorporate the genetics into this the feed efficiency?
Well, they simply use essentially correlations to look at linkages between various parts of the cow's genome and feed efficiency, or what other trait you want. And so now in the U.S., most cows, before they ever start to really look at daughters of bulls, is they're selected. We choose our bulls based on genomic predictions of feed efficiency, well, not feed efficiency yet, but milk production, health, longevity, all those sorts of things. And that's going to make rapid changes in the cows that we feed in the future. So my final point on here was, I have a list of things that I would love that we all think need to happen. We would love to see USDA help fund or prioritize, but in the end, I want to say that we need to consider genetics in all of this, because the cows we are doing experiments with today aren't going to be around in 30 years.
So are these traits measured? Like, I know that you have some funded studies where you measured the phenotypes of this.
Yeah, so you measure the phenotype on a set of reference cows, get equations based on their genetics that you then apply to the general population.
Thank you. I think that'll wrap up. Can we thank our speaker again?